You are watching video on SEE Class 10 Subject Science. In this video series, we are going to study chapters of Physics, Chemistry, Biology, Astronomy and Geology. Now, this part deals with Physics, Chapter 4, and it is Part 7 of the chapter. Now, in this part, we are going to study weight of a body on planets and the satellites. Now, we know that weight of a body is not same on different planets and the satellite. Okay, now that is because of the value of g, small g. Why does value of a body differ on different planets and the satellites? We are going to see here. Now, formula to calculate weight is W equal to mg. Here in this formula, small m is mass of a body, which is a constant quantity, and small g is acceleration due to gravity. And this value differs on different planets and the satellite. Okay, so why does this happen? We are going to see here. Now, formula for acceleration due to gravity is g equal to gm by r square. Now, in this formula, capital G is universal gravitational constant, and this is capital M. Capital M is mass of the planet or mass of the satellite, okay, which is a constant quantity, and capital R is radius of the planet or radius of the satellite. Now we are going to see these values in three cases. Now here, see, we are going to see the value of g, small g, acceleration due to gravity on the moon, on the earth and on the Jupiter. Okay, so we are going to see the value of g is different on different planets and the satellite. The calculation is done over here. Okay, why do we have value of g different on different planets and the satellite? We are going to see here. Now, moon, the mass of the moon is 7.2 into 10 to the power 22 kg. Radius is 1.7 into 10 to the power 6 meter. Earth mass is 6 into 10 to the power 24 kg and radius is 6.4 into 10 to the power 6 meter. Similarly, the mass of the Jupiter is 1.9 into 10 to the power 27 kg and radius is 71 into 10 to the power 6 meter or 7.1 into 10 to the power 7 meter. Now we are going to put these values in this formula and we are going to calculate small g, acceleration due to gravity. Now the calculation is done over here. Okay, substituting value, after substituting values, calculation is done over here, and after calculation the value of g on the moon is 1.67 meter per second square. You can check this calculation. And the value of g on the earth is 9.8 meter per second square, this one. Okay, and the value of g on the Jupiter is 25.13 meter per second square. On the whole, we use this as 25 meter per second square average value. Okay, so this way the value of g on the moon, on the earth and on the Jupiter are different. Now you see g on the moon 1.67 meter per second square, small g on the earth 9.8 meter per second square, small g on the Jupiter 25.13 meter per second square. Now we are going to put these values, substitute these values to calculate weight, and we will see how does weight differ from one planet to another planet or one satellite to another satellite. Now this is the calculation of weight. You see, measurement of weight. Okay, now let the mass of a body be 1 kg. Okay, we are going to calculate the weight of this body, same body, on the moon, on the earth and on the Jupiter. Yes, so we know weight equal to W equal to mg. Now we are going to calculate weight, W equal to mg, W equal to mg, W equal to mg. Okay, now here mass of this body is 1 kg. Okay, this 1 kg mass remains same on all cases. Okay, so mass is 1 kg and value of g is 1.6 meter per second square. Okay, g on the moon is 1.67 meter per second square. Now this value is substituted. Now on the earth, W equal to mg, W equal to mg and m is equal to 1 kg, same as here, because we are going to calculate weight of the same body on moon, on the earth and the Jupiter. So mass remains same, it is always same. So mass is 1 kg here also, but g is different on the earth, that is 9.8 meter per second square. Right now on the Jupiter, W equal to mg, W equal to m is equal to 1 kg. Again it is the same body, 1 kg, because mass does not change, and g is equal to 25, okay, on the whole. So after calculation we have found this weight. On the moon it is 1.67 Newton, on the earth it is 9.8 Newton, and on the Jupiter it is 25 Newton. Now we have seen weight of the same body is different on the moon, on the earth, on the Jupiter. On the moon it is 1.67 Newton, on the earth it is 9.8 Newton, on the Jupiter 25 Newton. So this way the weight differs on different planets and the satellites, and that is because of value of g not being same. Now we know that weight of a body on the moon is 1/6 the weight of a body on the earth, of the same body on the earth. It means, you see, 9.8 is bigger than 1.67 by almost 6 times, approximately 6 times, means actually this is 5.86. okay, if you multiply 1.67 by approximately 6 or 5.86, then that becomes equal to 9.8. okay, so weight of, because of this, weight of the same body is 6 times greater on the earth than on the moon. On the moon it is lesser by 6 times, smaller by 6 times. okay, so this is the reason. Now similarly on the Jupiter, what do we say is weight of a body on the Jupiter is 2.5 times more than that of on the Earth's surface. If you measure the weight of the body, same body on the Jupiter, it is 2.5 times more than on the Earth, and we have seen from this calculation only. okay, yes, so it means, you see, 25 is greater than 9.8 by almost 2.5 times. okay, so this makes the value more on the Jupiter. Now from this example only you can calculate, you can see 1.67 is almost 6 times lesser than 9.8. okay, or 9.8 is almost 6 times more greater than 1.67. That is why weight of the body on the moon is 1/6, means smaller by 6 times. okay, now on the Jupiter the weight of the same body is almost 2.5 times more than 9.8. right, so this is the calculation. So because of this reason, weight of a body, same body, is different on different planets and the satellites. right, weight of a body on the moon is 1/6 of the weight on the earth, means weight of the same body will be smaller by 6 times on the moon, and weight of the same body will be 2.5 times more on the Jupiter than on the earth. Now this is because of value of g, small g, acceleration due to gravity, and this acceleration due to gravity, small g, is different because of the mass and the radius of the planet and the satellite. okay, so with this we finish this part.